All right, in this last video, we're going to look at a couple of applications of right triangle trig. All right, and it's used sometimes when you're trying to determine the length of something that you can't measure directly. So like in the first problem, we're looking at trying to get the distance across a lake. And in the second problem, we're trying to determine what the height of a tree would be, okay? And so with the first problem, we already have the picture. That helps a lot. This is just like those problems earlier that we had with triangles. You just look at the information that they give you and you think about which trig ratio relates those. So you take a moment to look at how little a is opposite the angle and how 750 is the side adjacent to it. It's not the hypotenuse. That would have been over here. So you're looking for the trig ratio involving the opposite side and the adjacent side. So that would be tangent. So you know the tangent of 24 degrees equals a over 750. And then the rest of the problem is just solving that. So you multiply by 750. So we know a equals 750 times the tangent of 24 degrees. And then make sure your calculator is in degree mode. When you type it in, you get like 333.92, etc. This is a pretty imprecise measurement. You don't have to be so exact. They didn't tell us specifically, but it'd probably be fine to round to the nearest yard. So it's about 334 yards across the lake. Right now, the issue with the next problem is that you really don't have the picture given to you. So you have to try to think about where that 40 degrees they're talking about, what it deals with, okay? And so what we've got is a tree. Okay, so let me draw my tree. Here's my tree. Should have used green for that. So here's my little tree sitting here, okay? And then we have the sun somewhere up in the sky. So let's say it's right here, okay? So it's going to shine down. One of its rays might do something like that. And then here's the ground, right? So it shines down and hits the ground. All right, that 40 degrees they're talking about is this angle right here. Let me do it in red and clean up my picture just a little bit. Okay, so it came down here like this. Then here was my ground. And the 40 degrees was this right here, okay? That's the angle of elevation. So the angle of elevation from the ground to where you can sight the sun just hitting the top of the tree. Okay, that's what you kind of look at. All right, and then it says the shadow of the tree is 35 feet long. So when you think about that, it's like the sun would have forced a shadow to happen down here. Okay, all right, so your tree would have had a shadow there on the ground. Actually, it would have gone all the way to here, wouldn't it? Okay, like that. And you're trying to determine that shadow. It wouldn't have stopped short. It would have been, going all the way to where the sun hits the ground there. So this is the 35 degrees, okay? This is the height of the tree. So that's what you're looking for. That's your unknown you're looking for. And then we already talked about that being the 40 over here. This is the 40 that they gave us, okay? So we're looking for a trig ratio that involves 40. Oh, again, it's the side opposite, and again, it's the adjacent side. So this particular one would also be a tangent situation, and we'd have that the tangent of 40 degrees equals x. I don't know why I wrote a degree. I just noticed it. This right here wasn't degrees, of course. It was feet. We just fixed that. X over 35. And so then we'll solve that. So we'll multiply by 35. And we know x equals 35 tangent of 40 degrees. So we should already be in degree mode. So we just need to type in 35 tan of 40, enter, and we get 29.368. So that's going to be about 29.4. Okay. And did it say? It said to the nearest foot. So that would be about 29 feet tall. Okay. All right, so just wanted to look at just a couple application problems that use some of what we learned in the right triangle trigonometry section. Okay.